Hello everyone. Today we're going to talk about group chat application implemented using Bluetooth ad hoc network. We're Group 1 and our team is comprised of me, Tom, Caleb, Daniel, and Michael. So this is the table of content. We'll be talking first about the introduction, the main problem, why is it important to us, the roadmap, paper studies that includes three of them, and then finally we'll compare the papers and what and link them to our idea. So the main problem, as you all know, one cannot always be connected to the Wi-Fi network or cellular towers. So it's better to rely on another solution. So what is the other solution? Well, another solution to be able to connect to peer-to-peer is through Bluetooth. But however, there's also many solutions. But we will mainly focus on Bluetooth for our project. But what's the problem with the Bluetooth is distance mostly. So we need to implement a solution to this problem where people can find themselves too far away from each other and still can connect to Bluetooth via strings of network of connected peers. So why is it important to us? Well, mainly as I said before, in case of emergency, you won't have access to the internet. So there has to be another way to connect. And that will be really helpful if you can be connecting through Bluetooth and have multiple and be connecting either to people far away. That is why solving the distance issue is important to us. Here's a quick brief roadmap. So as I said, connecting to peer-to-peer without the internet, there are many solutions. One of them is Bluetooth, the other is Wi-Fi direct, and the other is radio. However, in our project, we'll focus mainly on the Bluetooth. As I said, the main problem with Bluetooth is distance. How do we solve that? Well, there's solutions such as the mesh network, the ad hoc network, or like having powerful antenna, or having multiple number of connection. We'll be mainly focusing on mesh network and ad hoc network as a solution. And to get a general idea on how to do that, we will be using three papers that we will introduce to you guys and have a brief summary about it. One of them is the Blemish, a wireless mesh network protocol for Bluetooth Low Energy device. The other one is a wireless mesh network tested in rural mountain areas. And finally, the last one, which is a performance comparison of multi-hub wireless ad hoc network. So the first paper, like I said, it talks about a wireless network protocol for Bluetooth Low Energy device. It's mainly what is the main problem about it? Well, as you all know, uh, Bluetooth Low Energy. It is a low power wireless technology that used to connect devices with each other. It is targeted mostly toward applications that need to consume less power. Uh, so how would it be able to connect to other devices? Well, as you all, this paper introduced the main solution, which is Blemesh, a wireless mesh protocol, which utilizes the broadcasting capability of a wireless network. This paper mostly wants to adapt a mesh network into BLE as a solution for this problem. Why is it adapting a mesh network? Well, as you all know, mesh network can host its own servers, so that we can communicate and exchange of information across the mesh network without having being able to connect to the internet. It is also less expensive to implement since the network are built with nodes that are consisted of mostly routers that can be purchased for less than $40. But also it is self-healing, and it has multiple ways to send the data across the mesh. Like I said, the paper uses the available data by using the Bluetooth Low Energy genetic access profile, adversarial data for different number of node, and send it into the batch. Then the study compared the blemish with the conventional routing method and floating method. So after comparing those two methods, the proposed method has less number of transmission compared to the routing and float, and the number of broadcasts in blemish is 54.5 smaller compared with the float, and 42.3 smaller compared with the conventional routing. So what is the strength of the paper? Well, mostly it is showing that the blush method is showing the blush mark is better by comparing with other network, and it also has reference of other work implemented, such as the Smash and Smart Mesh. The weaknesses is basically it's comparing those two methods and saying is better. It's not proving. It's not like taking any statistic or data that's saying, oh, there's actually benefit because it has its own advantages. No, it's mainly comparing to other method and saying it's better, which I found really not good. Now we'll move on to the second paper.
Hello, this is Thomas Creel doing Group 1's paper number 2, and the title of the paper is A Wireless Mesh Network Testbed in Rural Mountain Areas. And the summary of the paper is that a research team in Japan decided to tackle a problem of physical infrastructure being taken down caused by mudslides and earthquakes in certain mountainous areas. So they decided to use a system of nodes with 3 antennas with 5 dBi each, connecting to each other to use sort of a wireless mesh network for like hopping and sending data around that way instead of with a physical wired network. So, um, and the reason I decided to cover this paper was because it does kind of relate to our paper because we want to use wireless mesh networks as well. And we could even borrow the idea of using antennas for our network so that we can extend our mesh network even further. It's just another one of those ways that was also in the testbed. So continuing on to um, slide number 2, um, what we found and what this graph is showing is that we had what they had was a packet transmission successful ratio is 80% or more in both areas, about 70% of both areas. So what that means is that in about 70% of the areas in the two towns that these were located, 80% or more of the links were connected. And so that's really good. And it shows that the wireless mesh network was kind of solving the issue that they were having. One note on this paper is that um, this was kind of like a more of a failsafe, um, but it could be used just on its own. So when I say a failsafe, I mean that they had physical infrastructure, but they were using this to connect to government offices and that kind of thing so that they could still communicate to each other if the internet and cellular towers and all that, if they just did go down. So this was kind of, in a sense, more of a failsafe using a wireless mesh network. So that's really cool that we can use different technologies to cover the problems with other ones in the real world. And so, yeah, qualitatively, the connection is just much more robust as a failsafe. And what I like about this paper was that it, like one of the strengths of the paper, I mean, is that they actually did do the actual implementation of the test bed. So they did go out and put antennas in these mountain towns, um, and test it. And it was actually the towns of Takazawa and Mushigame. Now, one of the problems I had with the paper, I think, is that it was a very short, only a 2 or 3 pages long paper, and there's no way to be reproducible. They didn't really talk too much about how they did it, and maybe that's because it was related to like the government and that kind of thing. I'm not totally sure, but going back to how this would relate to our project with the wireless mesh network, we know from this paper that sending data across multi-hop connections is definitely doable because they did it here, and we also know that using antennas to send the data is also doable because that's also what they did here.
Hello guys, this is Caleb Steinmetz. In this paper review, we did a performance comparison of multi-hop wireless ad hoc network routing protocols. So in this paper, we used the NS2 simulator to simulate how DSDV, TORA, DSR, and AODV compare to one another. The metrics we used to compare were overhead cost, pause time, packet success rate, and path optimability. So the strength of this paper was that it did a comprehensive test using multiple metrics instead of just one metric, and also it showed a range of conditions with each of those metrics. The weakness of this paper is that they used an outdated version of NS. They used NS2. Also, this didn't include physical obstacles or inclement weather. Finally, the protocol does not actually, when it's using NS2, they didn't actually get real life data or anything. They basically just use simulation. So in the future, it would probably be better to actually have real life implementation of these protocols. So the success rate versus pause rate of multiple sources. If you look in these documents, we're comparing AODV, TORA, DSR, and DSDV. Each of these, we use 3 different amounts of sources, ranging from 10 all the way to 30, as we can see. TORA generally performed the worst, and as we can see, as the sources got exponentially larger and it got to reach to 30, that the packet started dropping and it basically was the worst out of them all. DSDV also seemed to struggle the majority of the time when mobility was much higher. So if you're wondering how we can detect mobility, the pause time tells how long each of these nodes stays in one position. It's using random waypoint uh, to basically determine where the node will go. So as we increase the pause time, the mobility of each node goes down. So as we can see with DSDV, the mobility when it's very high, it causes extreme packet loss. But as the mobility decreases, it gets very good success rates. If we look at AODV and DSR, we notice that both of them have pretty similar in terms of packet success based upon pause time. Uh, Basically, what we can gather from this is that the number of sources heavily affects TORA, while the other algorithms, it doesn't affect them nearly as much. For DSDV, mobility is extremely impactful on it for every kind, even if we keep the sources low. And then for DSR and AODV, both of them seem minimally affected as we increase or decrease the number of sources. And additionally, pause time seems to have the most effect on it, but that itself is also minimal. So if you're wondering what are the findings of this, DSDV performed well when the node mobility was low, but failed as mobility rose. Tora was a worse performer, but it still got over 90% of the packets between 10 to 20 sources. Where it really failed was when it had 30 individual sources. DSR was effective at all mobility rates, but had substantial overhead. Uh, AODV performed almost as well as DSR, but with substantially less overhead. So this made us think that AODV would probably be one of the better routing protocols for us to use for our topic.
Luckman and I will be doing the comparison of each paper. In these comparisons, we will look at the purpose, the method, and the outcome. The purpose found in the first paper is for an overview of a wireless mesh network testbed that will be placed in the mountains. This testbed is located in 2 areas and has a total of 22 nodes. This study measured the throughput and the packet transmission successful ratio of links in said testbed. Another purpose would be managing the system and its technical issues. These issues may come from being in such a rural, mountainous area. And lastly, experimental procedures were done to see the quality of the links in the network. The first purpose of the second paper was to introduce BLE Mesh. BLE Mesh is a wireless mesh network protocol which utilizes the broadcasting capability of wireless transmissions. The authors also compared BLE Mesh with other types of methods. These methods are conventional and flood routing. The purpose found in the third paper was to compare 4 multi-hop wireless ad hoc network routing protocols of different designs. This comparison is done using overhead cost, pause time, packet success rate, and path optimization. The method done in the first paper was to connect the nodes in the mesh by wireless interface. This is done by the control server at Niigata University via the control channel. Lastly, experimental procedures would be done for measurement of throughput of the links. The method in the second paper was to identify the available data payload. This is done by Bluetooth Low Energy Generic Access Profile, non-connectable advertising data for different number of nodes, and packets to send in a batch. The method of the third paper was done by applying a variety of workload to a simulated network. Then testing was done to each packet. These data packets originated by some sender whether the routing protocol can at that time route to the destination of that packet. Lastly, they had to measure the protocol's performance under a range of conditions. This study was not attempting to measure the protocol's performance on a particular workload taken from real life. The outcome found in the first paper was that the mesh networks were successful. The packet transmission ratio was at least 80%. Also, future work must be done to carry out the various experiments that were talked about in this paper. This will help to improve the performance of the network and consider the various application services deployed in these rural mountain areas. The outcome found in the second paper was that it was smaller than the flood routing, 55.5% smaller compared with the flood routing. It also was smaller than conventional routing, which was 42.3% smaller compared with the conventional routing. Lastly, a higher throughput and lower latency could have been obtained. The simulations were done under the assumption of one advertising channel in existence, but BLE Mesh has 3 advertisement channels and could merit from the utilization of all 3 channels. The outcome for the third paper was that DSDV performed well when node mobility was low but failed as mobility rose. TORA was the worst performer in the experiments but still delivered over 90% of the packets between 10 to 20 sources. TOR failed as the sources rose to 30 individuals. DSR was effective at all mobility rates but required more overhead to achieve this. And lastly, AODV performed almost as well as DSR but with substantially less overhead.
So we are going to be using these articles we just talked about mostly as a way to help us figure out what the best course of action and methods of connection and data messaging are going to be. For example, from Article 1 in BLE Mesh, it talks about the topic in general and creating a mesh network and using Bluetooth technology to create an ad hoc mesh network. This is the article we used just to figure out what we needed to do and how we're going to do it with what technology. Article 2 talks about a rural test bed that was created in the mountainous area, showing a proof of concept and that our idea will actually work using a mesh network in a disaster circumstance. Article 3 talks about a performance comparison between the different types of messaging systems and the routing algorithms used. We'll be using this article as a way to figure out which routing method we should use in our project, or if anything, we could use multiple in different circumstances. As to what the innovative design aspect behind our project is, we have not seen anyone talk about self-discovering networks, as in if we are in a disaster circumstance, we want to press a button and be notified who's next to us and create a network between us immediately. Most applications require 2 users to be next to each other and create a network by themselves using some sort of password or username. We think this won't work in ours because we want a disaster circumstance to be fixed in a press of a button rather than needing to find someone, and it just wouldn't work. So we would like to change ours to be more fitting to this context.